All right, we are back. I just had to take a quick break there, and we are going to do Module 2 right on the tail end of Module 1. If you didn't watch Video 1, I encourage you to go back to it. I went in depth on some formulas that are useful for the SAT. We saw something new that I haven't seen for a while with the trig. So good review for Module 1. Module 1 is usually a lot easier than Module 2. So if you're looking for a warm-up, I encourage you to go ahead and go back to that video. The second module is usually quite a bit harder, especially towards the end. So get your pencils ready, grab some scratch paper, pause the video if you want to attempt the questions along with me, and skip over the ones that you feel like you already know pretty well. But hopefully we'll go through this together and learn something about the new Test 7. All right, and I am using extended time and pause the clock capabilities just in case I need to pause and explain something that's a little unusual. And I apologize if I'm going a little too slow. For how many of these days did 15 days did the battery receive charge of 0? None of them. Zero charges on the x-axis. Be mindful of your axes, people. That's kind of how the ACT gets you as well. They'll try to change up your axes. So naturally, charge of 0 was received on 6 of these days. You'll notice that I'm skipping the top part there a lot. Which of the following is close to the slope of the line of best fit? I don't care that it's a scatter plot. They just ask about the slope of the line of best fit. So paying attention to the line, I need the slope. So I'm actually going to zoom in on your Chromebooks and whatever laptop you have. If you hold the control button down on your keyboard or and have a mouse, you can use the mouse wheel to zoom in, or you can use the pinch zoom. Or Control Plus does it too. Control Plus and minus will zoom in the Bluebook app. And I'm zooming in to look for where it's closest to going through a definite point. So I see 3, 7 as a coordinate point for sure. I don't really have anything else. That's probably why they're asking for the closest, because it's going to be really hard to get an exact value out of this. So 3, 7 is a definite coordinate point. 3, 7. What's another close one? Like 2, 5 maybe? I kind of want to go to an extreme point. Let's do like 6, and that's like 10 and or 12 and a half. 6, 12 and a half. And remember from our last video that slope is easily calculated by doing change in y over change in x, and it doesn't really matter the order. Let's go ahead and do y2 minus y1 this time. So that's 5.5 over 3, which is almost 2. It's a little less than 2. So I'm going to go ahead and go with 2 on that. We could check it again by picking, it's like really close to being 2. We could check it again by picking 2 different coordinate points. I'll check my math on that. Yeah. So let's pick 4, 7. I'm just going to round. Let's say we do 1, 3. So that's a change in 4 over a change in 3, which is 1.5. So again, we're closer to 2 than we are to anything else. Each time this goes up by 1, we're going up by just about 2. Yeah. All right, get this all the way on the screen. In a sample, 80% of the items are faulty. There are 88 faulty items in the sample. Oh, that's a high faulty frequency. How many total items are in the sample? All right. So they give us the percentage and the result. So 88 is 80% of what number? So 88 is 80% of what number? Make sure that my whiteboard is completely showing this time. All right. right, there we go. Get a little balance on the screen here. So of course we just divide by 80%. 80% is a decimal, and the actual mathematically useful number is 0.8. And divide 88 by 0.8. You guys know, I hate calculating in my head. It's 110. Always use your tools, never trust your brain, especially if you don't have to. Alright, the exponential function g, they do tell us this is exponential. What defines g? Okay, so I need to know the rate of growth in the y-intercept. They do give us the y-intercept, thank goodness. 0 for x gives the y-intercept at 1, the leading coefficient in an exponential function. You'll remember from our last video, is the leading term. So where's the note here? There we are. So in the function a equals p times 1 plus or minus r to the tx, the leading coefficient p is the y-intercept. So here that should be 1. There's only one of these guys, two of them, give a y-intercept at 1. These guys here are giving a y-intercept of -1. That's not the case. So it's either C or D. Cross those guys off. Now I need to know the rate of growth. It's clearly as x increases, the total value decreases, and the only way that's going to happen is if I have a ratio of growth that is a fraction or a decimal. So it has to be D. Think about it. You multiply by a number and it gets smaller. You had to have multiplied by a fraction. All right, if 8x equals 6, what is the value of 72x? Don't solve for x. Remember, don't solve for x. 8x equals 6. I want 72x, not x. What did I have to multiply by to get to 72? Well, 8 times 9 is 72. So 6 times 9 is 54. That's our answer. Nonlinear equivalent. We're just reducing h to the 15th over h to the 5th reduces to h to the 3rd. So I know that I'm going to have h to the 3rd in my answer, so it's either B or D. And just quickly looking at these q's, the exponent with the larger value is in the denominator. That's q to the 7th over q to the 21st. So clearly that's going to be in the denominator when we're all done. So it's got to be B. All right, we got a big word problem. Remember, the strategy here is to jump to the end of the text and read the question first. Which of the following best interpretation of this estimate? Okay, we got 23 pounds of oranges. To test the accuracy of the filling process, 344 boxes are chosen and weighed. So 23 pounds is the expected weight. We're choosing 344. Is estimated the average weight of all the boxes of oranges filled by the company in an 8-hour period is 23.1, with a margin of error of 0.19. So it could be as high as 23.29 and as low as 22 point whatever the subtraction of that is. It is plausible values for the average weight is between 22.91 and 23.29. Yes, I like A. Notice I'm letting them do the math for me. I suspect that from experience here that the math on these numbers is going to be correct. So don't worry about doing the math. Trust it. Plausible values for average weight of all orange boxes of orange filled by the company are less than and greater than. No, it has to be between. With margin of error is predicting the maximum and minimum for the average. So in a statistical analysis, the average for the sample is then predicted about the total population with a margin of error. So the predicted average is 23.1 plus 0.19 or minus 0.19. So it could be as low as 22.91 to as high as 23.29 and anywhere in between. That's where we predict the average to be. Because with statistics, nothing is a certainty. It's all an approximation. So it has to be A. Okay, we got a simple algebraic expression. Notice the repetition of x plus 6 here. They want what value of x is the solution. So I'm going to use that same strategy that we showed in the previous video, where if I have a repeated term, x plus 6, I'm going to say that that is a. And in my equation, I'm going to replace any of those repeated terms with the simplified expression a equals -8. And this is going to be a lot easier to solve, fewer moving pieces. 1/3 a minus 1/2 a, get a common denominator there, multiplying by 2/2, multiplying by 3/3. That gets me 2/6 a minus 3/6 a equals -8. 2/6 minus 3/6, of course, is -1/6 a equals -8. Multiply this 6 over. I'm going to go ahead and bring the negative over with it. And that becomes a equals 48. So if a is 48, remember a, we replaced x plus 6. So plug the x plus 6 back in. Equals 48. Then of course x equals 42. And you could plug it back in to double check if you really cared to. I'm not going to take the time. All right, we got something that looks complex, but remember on these that look complex, they are simpler than they appear. They say that the product of these things is equal to this polynomial. What is the value of b? Notice that b is a coefficient of x. So I've got an x squared term right here. That x squared term can only be the result of multiplying bx by -27x. There is no combination of terms that I am aware of when we multiply these that will have these x squared terms impact this x squared term. You can do the math out if you want. What you're going to end up doing is binomial foiling. First, outer, inner, last, for those who haven't heard that acronym before. X squared plus bx, 9x squared minus 27x. We're going to multiply each of these terms. First times first, outer, inner, last. And you can multiply that out if you want, but notice that bx times -27x, sorry for my handwriting, that's going to be the only thing that's going to result in an x squared. So I'm going to lock in on that. Bx times -27x equals -3x squared. We can basically just ignore the x's for the purposes of this exercise because I just want the numbers. So basically -27b equals -3. Divide the -27 over. That is 7. Sorry, I'm not an artist. B equals 3 over 27. The negatives cancel out, which of course is 1/9. So clever little ways that we can be efficient with our execution there. And the key is to just practice. All right, we've got coordinate point 0, 0. Parallel to the line. Parallel lines have what in common? They have their slopes in common. They are the same slope, different y-intercept. So if this is parallel, the equation for this guy is very simply 18x, because the y-intercept is 0. S passes through 0, 0 and is parallel. If S passes through 4D, what is the value of D? So just plug in 4. 18 times 4 is, of course, what? 40 plus 24 is 60. 40 plus 32, sorry. 40 plus 32 is 72. We got a function, it's a binomial pair. What value of x does it reach its minimum? This is code on the SAT. This is code. When you have pair of binomials, you've got basically a quadratic, right? That's an x-intercept and that's an x-intercept. Where is the minimum or the vertex relative to those x-intercepts? It is smack in the middle. So this distance here is equal to that distance there. And if those distances are symmetrical, I should be able to take these x-intercepts and find the middle. Well, obviously, if it's 44 and 46, what's exactly in the middle of those two things? 45. That's the x-coordinate of the vertex, the x-coordinate, where it reaches the minimum. They did not ask what is the minimum. They asked what x-coordinate does it reach the minimum. So 45. The wording gives it away. All right, we got triangles again. Only the second or third triangle question on the whole test so far. They tell us that y is a right angle. Always draw it out. X, Y, Z. Y being 90. Point P is on XZ. P. Q is on YZ. Q. PQ is parallel to XY. So we have a line here that is parallel to that one. Zoom in on this guy. Alright, so we got a pair of parallel lines. These guys are parallel. Clean that up a little bit. Those are parallel. If the measure of angle XYZ is 63, so XZY, so this guy here, 63. What is the measure of XPQ? XPQ. So they want this angle. Okay. So let's take a moment on this one. We'll enlarge the whiteboard. All right. So let's think about what we know about triangles. We know triangles add to 180, right? So if this guy here is 90 and this guy here is 63, this other one over here has to complete it to 180, or 63 plus this over here is 90, right? Because 180 minus 90 is 90, 63 plus this corner here is 90. So that's going to be 27, of course, right? And that is going to be true for our little triangle down here and for the larger triangle, XYZ. That's going to be true for both of those triangles. So angle P and angle X are both 27. Because these things, and that only works because these two lines here are parallel. So, because of that, I know what this angle here is. The straight line has to also be 180 degrees, right? So 27 subtracted from 180 is 153. And I'm sure there are several other ways to do that. But that's probably the best way for most students. More advanced math kids probably do that quicker, and a couple other ways that I can think of. But that's the best way for our purposes, I think. All right. Scary looking equations in our answer choices here. But let's read carefully and organize what they give us. In a set of 4 consecutive odd integers, where the integers are what? So I'm just checking our time. We've been at it for 19 minutes and we're at question 13. Not bad. In a set of 4 consecutive odd integers, so that's going to be stuff like 1, 3, 5, 7, and so on. Where the integers are ordered from least to greatest, fine, we did that. The first integer is represented by x. So x, notice this is increasing by 2 each time. Plus 2, plus 2, plus 2, and so on. Okay. The product of the 12th and 4th odd integer is at most 26. Okay. So the first integer, the 12th and 4th, or product of 12 and the 4th. So the 4th odd integer is plus 2, plus 2, plus 2. It's 3 plus 2's. So that's x plus 6 is the 4th odd integer. Take a moment to think about that if you need to. The fourth odd is 6 greater than the first odd. Because it's plus 2, plus 2, plus 2 to get to the fourth position. These 1, 3, 5, 7 is just a concrete example, by the way. It's just numbers that I'm using to keep myself oriented. So x plus 6 times 12 is at most, is up to, but less than, 26 less than, 26 less than, so it's going to be something minus 26. 26 less than, so I need a bigger whiteboard here. Yep, there we go. So 26 less than what? The sum of the first and third. So the first term is x, and the third term was x plus 4. So that's 2x plus 4, right, at the end of the day. 2x plus 4. All right. Oh, they didn't combine terms. They just left that as x plus 4 minus 26. So it's going to be a. My left-hand side, I'm pretty confident is correct. 12 times x plus 6. So that gets rid of c and d. And it's less than. Yeah, and just because it's less than, I can pick a. Good. That's a tricky one. Just read. Read carefully. Alright, we got a crazy looking system of equations. If you've done previous Bluebook tests, you will recognize this guy. This is very similar to a question which I believe is on test 6. Let's go ahead and go through it. This statement here that g and k are constants, I get students asking me about that all the time. Telling me that a number is a constant is mathematically useless. That's like telling me that 2 is a constant. Of course it is. 2 is 2. This does not mathematically help us solve the question. This, on the other hand, does mathematically help us solve the question. The system has infinitely many solutions. What does that mean? For a pair of linear functions to have infinite solutions. Infinite solutions means they're the same line. Their slopes and their y-intercepts are the same. So in the standard form, ax plus by equals c, the slope is negative a over b. The y-intercept is c over b. They gave us the number here, 2/7 and 5/2. That I don't think is going to be useful for us. They're asking for g over k though. Notice that that follows the same pattern as our slope equation. G here is corresponding to a, k is corresponding to b. So if I just get these terms over each other, 2/5 and 7/5, that should be equal to g over k. So they should be equal, I believe. I might need to do some shenanigans with scaling this up appropriately, because this number here is not the same. So let me think about this for a moment. So if these things have infinite solutions, their slopes are the same. So negative g over k is equal to negative 2/5 over 7/5. We know that because the slopes are the same. Negative g over k. Oh, because this is a ratio, we don't actually care about scaling it up. The ratio, and I'm just thinking about that, the ratio would end up canceling out. So the negatives pop off, just becomes positive and positive. We can reduce this fraction, g over k. Come on, k. There we go. G over k is 2/5 times 5/7. Remember, when you divide by a fraction, you can instead multiply by its reciprocal. Those reduce, and you get g over k equals 2/7. And don't be afraid if you get a fraction. That is a perfectly acceptable answer. All right. We got what? We got values. There we go. That's what I'm looking for. It's a linear relationship. So what's going on with these x values? That's kind of unusual that we're multiplying by something here. We're not adding. Usually in a linear relationship, you're increasing the x by a constant term. Here we're like multiplying. So basically these are going to end up being ratios, I bet. Oh, we can use the slope. I think it's the same kind of idea where they want us to use that same definition. I bet this is going to end up using the same concept here. Okay, let's do it. Okay, this is number 15. Okay, so they give us, should I use change in y over change in x? Yeah, we could just use the straight up definition. There's nothing wrong with that. So change in y, 3. Change in x, s. Right? Or it went down 3. Let me just do it out. 24 minus 21 over negative 2s minus negative s becomes plus s. Yeah, that'll end up being negative, won't it? Or no, that'll be positive up there. 24 minus 21 is 3. Negative 2s plus s, because you're minusing a negative. Just negative s. So the slope is negative 3 over s, or whichever is negative, who cares? But I am going to go ahead and back in to that same negative a over b definition for slope. So 3 is in the numerator, so I know that it's not a, and it's not d, because 3 is the coefficient on x. I very likely shouldn't have an s on my y-intercept. I'm gonna go with c here real quick. Oh, that's the only difference between b and c, isn't it? Yeah. You could double check this by plugging in s for x and 15 for y, and indeed that one works out. Because, yeah, this would have an s on it. These should have s's on it if b were correct. Weird question. Highly conceptual. I bet a lot of people are going to get stumped by that one. All right. Given system of equations, k is constant. Again, that's mathematically useless. Notice that, again, that we've got, if you watched the last video, we got a similar scenario here where we've got systems of equations where if I just add them together, these terms would cancel out. But I don't want that to happen. It's saying, what's the value of k? I want to solve for k. I don't want k to cancel. So what are we going to do here? Could I still solve it? No, it says it has one distinct real solution. Whenever they tell you the number of solutions, that's telling you to use the discriminant. And remember from previous videos, the discriminant is b squared minus 4ac. And if it has one solution, that's equal to 0. So I need to get this into standard form where I can plug in b, a, and c and solve for k. K will fit into probably the c compartment there. Let's get this into y equals format. So y equals x plus 26 minus k. Y equals x squared minus 5x plus k. We're going to set them equal to each other because it says there's the solution to the system has one solution, not that that equation has one solution. I'm going to set them equal to each other. X plus 26 minus k equals x squared minus 5x plus k. Get everything to one side. Bring this whiteboard to the front again. I'm going to just bring everything over to the right. We got x squared minus 6x, subtract the x, subtract 26, add the k. Now we jam it into our discriminant, the b squared minus 4ac equation. So b squared is 36, minus 4. A is 1. C is this whole thing. Negative 26 plus 2k. That all equals 0. Okay, now it's just more algebra. 36 minus 4 times 1 is 4, of course, so that can be ignored. Negative 4 times negative 26 is going to be positive, what, 100 and something. My brain's not braining today. 4 times 26 is 104. Don't be afraid to use a calculator. And it's positive 104, and this is going to be negative 8k equals 0. And now you can see that we're going to get a solid number out of this. 136 plus 100, or 36 plus 104 is 140. Bring that over and divide by negative 8. So k equals negative 140 divided by negative 8. K equals whatever that is. I'll zoom out again to use my calculator. 140 over 8 is 17 and a half. Perfectly valid answer. It would accept if we left it as a fraction. I would of course encourage you to reduce the fraction, but if we left it as a fraction, it would be acceptable. All right. That one was a bit chunky. I encourage you to pause, rewind, go back and watch that one. Really digest it. This phrase here, exactly one distinct real solution, was the key to success on it. All right. Functions defined by this linear guy. What's the value of f of 4? Oh, little gimme here towards the end. 1/2. Plug in the 4. 4 plus 6 is 10. 1/2 of 10 is 5. Little reprieve there. I'm going to double check I didn't miss anything here. 1/2. F of 4. 5. Yeah. Okay. Area of rectangle banner. I always like to draw the picture. Length is x. And x, the length is 24 more than the width, it says. So if the length is x plus w, the width then is of course going to be w minus 24. X minus 24. X minus 24, because you bring that 24 over, and that's the width, and that's both sides in terms of x. And of course, length times width gives the area, so x times x minus 24 gives us 2661. And if we deal that out and set it equal to 0, we'll end up with a minus 2661. Our x squared is positive, of course. X squared minus 24x. And keeping track of the positives and negatives, that's kind of what we're being tested on there at a certain level. Obviously, the setup is part of what we're being tested on, but also track error negative. Hey, geometry finally. A right circular cone has a volume of 71,148 pi cubic centimeters, and the area of its base is that. What is the slant height? Okay, so they do give you these equations, but I do encourage you to memorize them. The area of the base, it's a circular cone, so the area of the base is pi r squared, and that's there to give us the radius. 5929 pi. The pi's cancel off, and you take the square root of 5929, and that gives us our radius. So square root of 5929 is 77. But we're not done. I see that's one of the answers. They want the slant height of the cone. So a cone, roughly speaking, is going to look like that. It has kind of a coney shape to it. Imagine this is all curved. So the radius, which we just calculated, is 77. That's the radius. They want this slant height here. So to get that slant height, we're going to use the volume equation. But the volume equation doesn't get us there right away, because in our reference here, that's using not the slant height, but the actual like perpendicular height. So we're only part of the way there. 1/3 pi, r here is 77, so 77 squared, which is just 5929. We could have shortcutted that a little bit. Times h is going to give us the height of this guy. And let me show you where we're going with this. Once I have the height here, I can do the Pythagorean theorem with 77. Draw a little triangle there. That's a right triangle in there. The height through the center is what we're about to calculate. And then the Pythagorean theorem with 77 in that height gives us the slant that we're looking for. This is 71 and 148. 148 pi. Pi's cancel out yet again. Multiply by 3, divide by 5929. So h equals 71 148 times 3 over 59 29. Calculator again. So 71148 times 3. You could just type all this in. Divided by 5929. And the multiplication and division does not care what order you do the multiplication and division. So the fact that it's like that doesn't make a difference. Like if I did 71 148 times, that should still give us the same answer, 36. So the height is 36, not done yet. I'm betting it's 85. So h is 36. The radius was 77. And it must be 85 because the Pythagorean theorem is going to give us a hypotenuse that's greater than any of them. But if you want to go ahead and do the math on that, I encourage you to go ahead and do so. But that would be the next step. 77 is the base of the triangle. 36 is the height of the triangle. Do the Pythagorean theorem to get the slant. I'm confident enough, but I'm just going to move on. And this is why I'm using extended time, because we just passed 37 minutes and we have 3 questions left to go. Because I know by explaining these, I'm going to take more time than just doing them in my head. And then another recognizable SAT question here. If you've done tests 1, 4, and 5, I think there's a question like this on each of those, where notice the y coordinate here, and the x coordinate and y coordinate, these are all in y equals mx plus b format. So what they did here is they said, okay, if r is the x coordinate and you rearrange it to get y equals, which one arranges it correctly? So that's all I'm going to do. They probably tell us for each real number r, which of the following points lies on the graph of each equation. Yeah, these are the same equation, aren't they? These are just multiplied by 4, and you get the same exact thing. They don't even bother telling you that it has infinite solutions. We should just recognize that. So just plug in r for x. And the only way to do these is plug and check, by the way. That's really the only way to do it. So plugging in r for x, we get 7r plus 6y equals 5. Rearrange to get y equals. We get y equals negative 7r over 6 plus 5 sixths. So that gets rid of a. Let's see, it's negative 7r, so I know it's not b. It could be c. Let's go ahead and plug in r for y. Rearrange to get x equals, because that's what d is doing. If r is y, 7x plus 6r equals 5, and rearrange to get x equals, we'll get x equals negative 6r over 7 plus 5 sevenths, and we end up getting d. I have never once seen the answer be something like c. in order to solve that, you would end up saying, okay, if this is x, plug it in for x, solve for y, and do I get this? That would be crazy. I've never seen it be the correct answer, though. It could happen, though. All right. All the answer choices are linear functions. This feels like a gimme. Which of the following functions gives this for d days, where d is a positive integer? Yeah. 52 for the first day, 26 for each additional day. 26 is the slope, and 52 is the y-intercept. So if it's day 1 is the key here. Yeah, the first day is 52, so that's actually coordinate point 1, comma 52. That is not 0, comma 52. And it's 26 for each additional day. So we got to keep in mind day 0 exists. So I'm confidently going to be able to say A, because obviously we're not decreasing by 26. We don't have an initial value of 78. We have an initial day 1 value. If I plug in 1, I get 52 for A. Very simply. That was a gimme. All right. Number 22, speed of a vehicle is increasing at a rate of 7.3. Our first unit conversion, and it's the last question in the whole thing. All right. I just realized you guys might not have been able to see some of these questions. All right. Anyhow. Speed of the vehicle is increasing at a rate. So that's not the speed, that's the kind of the slope, but this is a unit conversion. Miles per minute. They give it to us in meters per second. So 7.3 meters per 1 second is equal to how many miles per minute? Second squared for 1 minute squared. All right, we'll call that x. So to convert this, go ahead and bring my whiteboard to the front again. They do give us that unit conversion, and that's what gives it away. So 7.3 meters. I'm going to convert the meters to miles first. We're going to leave the seconds alone. Times, I want miles in the numerator, so we'll do 1 mile over 1609 meters. The meters unit cancels off, and that should give me the conversion into miles. Now we'll convert the seconds, so times. I want this in minutes squared, so seconds squared to minutes squared. I don't like that. So how many seconds are in a minute? Well, 60, of course. 60 seconds squared? Or do I need to do 3,600? What do you think? Is 1 minute squared? Yeah. I'm pretty sure that's the conversion we're going to need because we're using squared time here. So let's go ahead and just jam that through our calculator. And I'll double check my work. Times 3,600 divided by 1609. 16.3, and I think they're going to ask what is rounded to the nearest tenth. 16.3 is to the nearest tenth. If I just did times 60, yeah, we don't even get a whole number. Yeah, it would just be 0.3. So it's either A or B, right? Now, because of the way I know that like my stoichiometry brain isn't turning on, but I'm pretty sure that we need to square that to make sure the units of measurement work. Because what is this essentially saying? If we think about the math, that's times 1 second times 1 second. So to convert both of those seconds, we need 60 seconds in 1 minute, and then 60 seconds for another minute. And combining those, we get 3,600 seconds squared over minutes squared. So I'm pretty darn confident in my 16.3. All right, let's see how we did. That's the end of Module 2. Of course, I didn't go over scores in in my attempt of Test 1, Module 1, because obviously it wasn't computed. Let's take a look. I clicked View My Score. Let's sign in. Just in case you guys try to hack my thing, my username and password is not real. It's just a fake account that I make for the purposes of this thing. All right, let me get this up on the screen. Browser window. Bear with me. There we go. All right, bring that down. So you'll notice that my score is, of course, not perfect in any of these. That's because I'm doing a couple modules at a time. And today we got a 790. Not bad. Let's check out our score details. Right. Reading, who cares? We skipped it all anyway. There it is. I jumped right to it. Oh, we missed 2 questions. All right. Everything correct through Module 1. Number 15 is incorrect. Number 6 was incorrect. 6 and 15, and that was it. All right, let's go ahead and review those real quick. Really? Oh, duh, because I was using ratios. You don't divide when you have division there. You subtract the exponents, obviously. Yes, so the answer, of course, is A. Indeed, h to the 15th divided by h to the 5th, of course, is going to result with h to the 10th. Because when you divide by like terms, you subtract their exponents. And number 15 was my other error. Not the ones I expected to get wrong. Why isn't it advancing? There we go. This one. The correct answer is B. Why is that? Why is that? Why? Changing Y. We're changing X, right? Let's think through this. I was so confident. Think through this guy. Over here. Doesn't make intuitive sense to me, at least not at first glance, why the answer should have an 18S. There. Read the question, make sure there's no shenanigans happening. Yeah, it does not say anything's shifting or being crazy over there. Bring our whiteboard up. Alright, let's think and analyze what's going on here. And this is what I encourage you guys to do when you make a mistake, is to learn from it. Alright, changing Y. Changing Y. Or changing X. So that's what we did. We did 24 minus 21 over negative 2s minus negative s, so that should be plus s. We get 3 over negative s is the slope. That should be equal to negative a over b in our expression. So 3s. So if all of our expressions have that, 3 should be in the numerator, so it narrows it down to B or C, which I think we determined earlier. Doing the slope for b gives us what? Gives us -3 over s, and they both give us the same slope. The only difference between those expressions is the y-intercept, which we cannot possibly know given what we've been given here, I guess. We could figure out what s is, I guess. Like, because these are like coordinate points, right? So if I have s15, negative s21, that went down by a factor by 2s and up by, so the change there, yeah, 6 over negative 2s, but that doesn't help me. That just gives me the same slope again. But I actually have the amount. Y equals mx plus b. Plug in what you know. 15 equals -3 over s times x plus b. 21 equals -3 over s. X here is s. X here is negative s. Plus b. So that should give us the y-intercept. So these s's of course cancel out. That becomes 3. -3. So adding that, we get b equals 18. Does that hold? Yeah, that holds true for both those statements. So we got the y-intercept. The y-intercept is 18. Okay. Well, there it is. All right, that's sneaky. Okay, if the y-intercept is 18, in standard form, ax plus by equals c, the y-intercept is c over b. And if my y-intercept is supposed to be just 18 with no numbers on it, like I said earlier in the video, I don't want any s's on this thing. B has to contain an s. And like if B already contains an s, like option C over here does, then this has to contain an s as well. So we'll get 18s over s, and that cancels out to 18. Damn. That is some sneaky shit. Cool. I learned something there real quick, and I hope to see more questions like this. I think it's a critical thing for kids to encounter, to be thinking critically about what it means to be a linear function, applying their y equals mx plus b formats. Thank you for watching. If you learned anything with me today, if you learned from my mistakes, if you learned from my explanations here, you just want to see more of these, please give me a thumbs up, a like, and a subscribe. Leave a comment down below and share it with your friends. Thank you for watching and sitting through it with me. Bye now.